So we're going to start chapter 9. You have it right here. You need a pencil, calculator, highlighter, and I think that's pencil, calculator. Chapter 9 is about trigonometry. What shape is trigonometry about? A triangle. Yeah, triangles. In Algebra 2, there's a whole other chapter about it. You review what we learn now in like 2 sections, whereas we learn it in about 3, 4, I don't know. And then if you move on to like college maths, you do trigonometry again. It just gets harder. So it's all about triangles. So just keep it simple. It's a weird word for triangles, right? The study of triangles. You have a quiz on Wednesday. It's over SOHCAHTOA. If you took maps and you saw the word sine, it looked like sin, but we call it sine. Cosine, which looked like COS, cos, or tan, which is tangent. It's just ratios that you have to memorize what goes where. A ratio is a fraction. Anyway, SOHCAHTOA is an acronym. So an acronym is like TCA, stands for Trinity Christian Academy. Each letter stands for something. You have a quiz over that on Wednesday. It'll be super duper short, like 3 questions, maybe 4. And then next Friday, you have a quiz. Even though my daughter erased it, it's right there, that Friday. It's just over what we learn. A lot of the sections are really repetitive. So there's that. All right, so today we talk about the Pythagorean Theorem. And I'll show you a picture of our good friend Pythagoras. I mean, I guess that was a good enough picture. Pythagoras was an interesting dude. Back in the day, like in the BC times, they had nothing to do, right? They didn't have TV, they didn't have, So I'm not kidding you, they just stood around and smart men did math and they made clubs because they just discovered math, and that's all that they did. And they're like, what if we did this? And what if we did that? Because that's what they had in their lives. And then, some people like Socrates and Plato, and like you've heard these names. They did more like philosophy. But anyways, this is what he looks like. He had weird beliefs, personal beliefs about like the sanctity of life and food. I'll show you that in a second. But he's much like Columbus with the Pythagorean Theorem. What did Columbus do? He discovered something that was already discovered. That's the perfect way to say it. So Pythagoras came upon the Pythagorean Theorem, a squared plus b squared equals c squared, and he was like, wow, this isn't named. I know what to call it, right? And the reason is, if you go back to Babylonian times, and even if you go back to the pyramids, they actually use the Pythagorean Theorem. They just don't call it that, and they obviously don't use the letters A, B, and C. But it's the same property that they use. He was very interesting. You'll see in these pictures what happens when he died. All right, he formed all of these smart men formed clubs, essentially. Exclusive clubs where you had to do certain things to stay in the clubs, like stay silent for 5 years. He believed he was vegetarian. He didn't want dead carcass in his soul. He prayed to the number 10. Don't know how you do that, but that's that. That was their symbol, their logo, if you will. Legend says he killed a man for discovering an irrational number. It took a long time for people to come to terms with the fact that there were numbers that didn't end, like decimals, like 1/3 doesn't ever end, things like that. And so, I don't know, when you're smart back in the day, that was your legacy, and that was your, it was prestigious. And I don't know, someone disagreed with him, and he probably made a good point. So legend says he killed that person because, couldn't have someone smarter than him. But anyways, his demise came from he was meeting with the Pythagoreans, and a group of men were tired of him and tired of not being a part of his group. So they set fire to his building. He did get out, but then remember how I said he has weird thoughts and beliefs on, he came upon a field of beans, but he believed that beans, had a thing to do with your previous life. I don't know. So then they caught up to him. He couldn't get around the field of beans before they caught up to him. And so he died. Rip. And then it's quoted in his language, but I would rather die of slaughter than run on beans. And so he did. And that's what he said, yeah. So according to the first slide was the book that I read. I have a math degree, and you have to learn about mathematicians, and this was the one I learned about. But anyways, he's a weird dude. Now we have the whole thing named after him. Maybe you'll remember it, maybe you won't. But Pythagorean Theorem. It's like the foundation of trigonometry. All right? So you've heard of it before. Your book is going to refer to it like this. I don't think that's helpful in the long run. We call it a squared plus b squared equals c squared. So go ahead and fill it in at the top. A squared plus b squared equals c squared. So in a right triangle, there are 3 parts to the triangle. There's 2 legs and then a hypotenuse. So the legs will always be A and B, and then C will always be the hypotenuse. Okay, C will always be the hypotenuse. The other 2 legs are interchangeable as A and B, but C absolutely matters. It has to be the hypotenuse every single time. How do we figure out which side is the hypotenuse? It's the longest side, and it's across from the 90-degree angle. Good. So it's longest side and across from the right angle every single time. It goes along with what we learned in Chapter 6. The biggest angle in this triangle is the right angle, so therefore it should be across from the longest side. The smallest angle is across from the smallest side, that kind of stuff. All right, so here's what's going to happen. I used to, when I, had less students and, free time, more free time, I would bring a box of Cheez-Its. 'Cause what shape is a Cheez-It? A square. So it says that a squared plus b squared equals c squared. So if you look, we've got, what is the length of A over here? 3 boxes tall, right? And the length of B is 4, and the length of C is 5. So 3 as a square, which makes, 9, plus 4 squared, which makes 16, equals 5 squared, which is 25. So this is how I would have proven to you kind of the Pythagorean theorem. But I do want you to remember 3, 4, 5. It's the most common, what we call it, a Pythagorean triple. A Pythagorean triple is just 3 whole numbers that make a squared plus b squared equals c squared. 3 whole numbers. We'll talk about it more here, I think on the next slide. Yeah. A Pythagorean triple is when you have 3 positive numbers that satisfy a squared plus b squared equals c squared. I will say my husband used to build houses, and a lot of things in houses have to be right angles, right? I mean, in order for things to stand properly, in order for doors to close, windows, things like that. So a lot of people in construction actually memorize Pythagorean triples. So I think if we were making this doorway, they would measure the length and the width, and then then they would know the diagonal, or they would measure the diagonal however you want. And then they would know if it's correct. So you don't have to memorize any Pythagorean triples, but it is in this section going to ask if it is a Pythagorean triple. Here are some examples of them. Again, it's really just 3 whole numbers that make a squared plus b squared equals c squared. Okay, so with these 3 examples, we're going to find the value of x and then tell whether the lengths form a Pythagorean triple. So again, Pythagorean triple, we want all whole numbers. That's our goal, to find out if it's a Pythagorean triple. All whole numbers. So we're going to do a squared plus b squared equals c squared. Which of these is going to be c? X. And then 81 and 108 are going to be a and b. To square in a basic calculator, you just multiply it times itself. So go ahead and type in 81 times 81. What do we get? 6,561. Okay, plus 108 squared. 11,664. Okay. Equals x squared. We're going to leave the x squared alone until we have everything combined on the left side. What is 6,561 plus 11,664? It's what? 18,225 equals x squared. So I have a lot of students stop here, but would this triangle make sense if my other one had a length of 81 and my other one had a length of 108, and then we said the last one had a length of 18,225? It doesn't sound like it's in the ballpark. So make sure you do the last step. That's what x squared equals. So what is the opposite of squaring? Square rooting, if you will. So we're going to square root on both sides. So just hit the square root button and you get 135. Okay, so is this a Pythagorean triple? Yes. Those are three whole numbers, 81, 108, and 135, that make a squared plus b squared equals c squared. How do we feel about it? Beautiful. In number 2, which of these is going to be C? 8. Yep, across from my right angle. So we got to use 8 squared, which means x squared and 4 squared are A and B. We're going to leave x squared alone, just drop it down. What is 4 squared? 16. 8 squared is 64. Subtract 16. X squared is 48. Take the square root. This is not going to be a perfect square because 49 is a perfect square. Is 6.9, yeah? Okay, and then is this a Pythagorean triple? No. All right, the last one, I'll let you try on your own. So the square root of 625 is 25. Is this a Pythagorean triple? Yes. You don't know it, but it's actually the most basic Pythagorean triple. Here's why. 15, 20, and 25 are all the side lengths. Let's go ahead and reduce them. What are they all three divisible by? 5. 15 divided by 5 is? And then 20 divided by 5 is? And then 25 divided by 5 is? 5. So it's one of the most, it's a multiple of them. All right, so the first thing that the Pythagorean theorem is good for is finding the missing side in a right triangle. We're going to use it here. I know that you know things about north, south, east, west, but I just want to clarify one part as well. Let's go and draw a compass. Never eat soggy waffles. I think everyone knows that. But what you need to know is how this links to a right triangle and how it links to the Pythagorean theorem. North, south, east, and west are perpendicular to each other, which means they form a 90-degree angle. So anytime you have north or south meet east or west, they form a right angle. So all of these technically would have a right angle. I just drew one. So anytime you have one of these problems, and you have north or south, and then you have east or west, you need to put a right angle between wherever that turn is. So we're going to read the first sentence, then we're going to draw a picture. From school, you biked 1.2 miles due south and then a half mile due east to your house. So starting with, we started at school, so I'm going to put a dot and call it school. And then which direction did we go? South. So we went down 1.2 miles south. And then we went 0.5 miles due east. 0.5 miles east is to the right. And then to your house. So again, anywhere south and east meet, there's going to be a right angle at their intersection because they are perpendicular to each other. So it says, if you had biked home on the street that runs diagonal from your school to your house, how many fewer miles would you have biked? So there's a street diagonal from the school to the house. We want to figure out how many fewer miles you would have biked. So first we got to figure out how many miles we did biked. Oh, that was terrible. So sorry. How many miles did we bike? 1 point what? No. We biked 1.7 miles. I think you worked ahead, but we aren't there yet. We biked 1.7 miles. We want to figure out how much we would have biked if we had biked the diagonal. And then figure out how many fewer we would have biked if we had biked the diagonal. So, how do we find the length of the diagonal? Correct. The Pythagorean Theorem. Which of these is going to be C? X, yeah, the one we don't know. So we've got 1.2 squared plus 0.5 squared equals, you can call it x squared. .2 squared is 1.44, and then 0.5 squared is 0.25. Add them together, we get 1.69 equals x squared. Take square root. So then how long is the diagonal? 1.3. So if we had biked the diagonal, we would have biked 1.3 miles. In the end, it's asking how many fewer miles would you have biked if you had done the diagonal instead. So what do we have to do there? Subtract. So how many fewer miles would we have biked? 0.4 fewer miles. All right, when you're ready, you can turn the page. So you can use the Pythagorean Theorem to find the missing side on a right triangle. You can also use it to figure out if you have a right triangle, or what kind of triangle you do have. So in this part, we're going to decide if we have acute, right, or obtuse triangle using the Pythagorean Theorem. So starting with, is it a right triangle? If it's a right triangle, then a squared plus b squared equals c squared. So we're going to plug in a, b, and c, and then see if a squared plus b squared equals c squared. So we've got some things to talk about beforehand. On the back, go ahead and flip to the back really quick. You need to know how to do this without a calculator, like without a scientific calculator. You also will need to know how to do it correctly in a scientific calculator. So I would find space to write down these three things. We're going to talk about squaring a square root. It's something you learned in Algebra 1, and probably before that I just know about Algebra 1. So just go ahead and you're writing these down, all three of these. Square root of 5 squared, and then you got some parentheses, 2 square root of 3 squared, and then 2 square root of 3 squared. We'll start from the most basic and then work our way up. But you need to know how to do this without a scientific calculator. So, I'm going to show you the why your answer is the way that it is, and then show you the shortcut. Okay? So, square root of 5 squared. What's happening when anything's being squared? It's being multiplied times itself. So technically, this is the same as the square root of 5 times the square root of 5. The square root of 5 times the square root of 5 is the square root of 25, which is 5. And the reason that this is is squaring and square rooting are opposites of each other, right? So what happens is the square and the square root, they actually cancel each other out. And the answer will always just be that number under the radical. Every time. Because squaring and square rooting are opposites. They cancel out. This is the long processed way to show it, but you could also just know that they cancel each other out. The next two, that was just the introduction. The next two, what is the difference between the two pictures? Or the two problems? The exponents outside of parentheses. So what's being squared in this first one? All of it. 2, the square root of 3. What's being squared in the second one? Just the square root of 3. So eventually you will be allowed to use a scientific calculator. And if you type in the second one, it will not be the same answer as the first one. Because your calculator is going to say, hey, in the second one here, they're only squaring the square root of 3. Whereas this first one, they're squaring 2 and the square root of 3. So make sure you're able to type in both. But you also need to figure out how to square both. Okay? So I will show you. Just like we said, these parentheses show that both of them are being squared. But first, let's talk about what 2 square root of 3 means. We'll go back to the basics. What is 2x? What's happening between a 2 and a letter? It's being multiplied, right? So when you have 2 square root of 3, it is the same process. These two are being multiplied together. There's just no little dot there. It's understood. So when we square, we're going to square both of these and realize we're going to multiply them after we square them. So here's what that looks like. It'll look like 2 squared. Put your little times, and then square root of 3 squared. This is essentially what your calculator is doing for you if you eventually type it in. What is 2 squared? 4. And then the square root of 3 squared. 3. And then 4 times 3 is 12. Whereas the second, there are no parentheses, so this 2 is just out here. Nothing's happening to it. We have 2 times the square root of 3 squared. So nothing's happening to the 2. What is the square root of 3 squared? 3. And 2 times 3 is 6. So we're actually off by half, by 50% if you will. So make sure you know how to square both. Okay? We're going to apply it here, as you can see in these 2 examples back on page 2. Tell whether this is a right triangle. So if it's a right triangle, then a squared plus b squared equals c squared. A squared plus b squared equals c squared. So c will always be the longest side. So which of these would be the longest side? The square root of 113, sorry. All right, do not turn it into a decimal or you're going to have a decimal answer, and that's just it's not necessary. This is super easy if you leave it like this. That means a and b are 8 squared and 7 squared. What is 8 squared? 64, and 7 squared? It's 49. And then what is the square root of 113 squared? 113. Those squared and square roots cancel each other out. So what is 64 plus 49? 113. So yes, this is a right triangle. I want you to be in the habit of writing what kind of triangle it is, because in a second we're going to decide if it's not right, if it's acute or obtuse. Questions about this first one? Okay. The second, we're going to do the same thing, a squared plus b squared, and see if it equals c squared. Which of these is the longest side?
4 times square root.
Correct. So before we even start, so I know some of you have already tried starting. Pause. If you want to see if it's the longest side, if they look extremely close, I would say these do look pretty close, but you can probably figure out this is the right angle. But if not, and you want to figure out approximately what the decimal value is, not that we would use it in the problem, but just figure it out. Go ahead and type in 95 into your calculator, and then the square root, and then multiply times 4. So what is the approximate value of 4 square root of 95? 39? 38 point something? Yeah. Yeah, so that's why it is the longest side. We're still going to use the radical form, but just if you were questioning it in later in a problem. But that is our C. This is why I taught you about the parentheses. If I just put this square here, is all of this being squared? It is not. But I want the whole side to be squared. So you do want parentheses. And then the other two would be 36 squared and 15 squared. What is 36 squared? Should be a large number. 1,296. Okay. And then 4 square root of 95 squared. So I'm gonna take it over the side so we can practice this again. So remember, a number in front of a radical is being multiplied. You're gonna square both parts. So 4 squared times the square root of 95 squared. 4 squared is 16. The square root of 95 squared is 95, and then 16 times 95. 1520? Last thing to do is add the left side. What is 1296 plus 225? 1,521. So is this a right triangle? No. So not a right triangle. I'll actually tell you what kind it is because we're about to learn it. In a second, we'll use the Pythagorean Theorem to decide if it's acute, right, or obtuse. This is not a right triangle. It's either acute or obtuse. What is the most important side of a right triangle? The hypotenuse. So here's what you do, and you can write it down just as a, precursor of what we're about to do. 1,520 is the hypotenuse squared, correct? It is smaller than a squared plus b squared. If the hypotenuse squared is smaller, this is going to be an acute triangle, which is what we're about to talk about. If the hypotenuse squared is smaller, that would be acute. If it is bigger than a squared plus b squared, then it would be obtuse. And if they equal, it'll be right. So that's the last piece of this lesson, is not only saying it's not a right triangle, but deciding what it is. So we're going to look at the hypotenuse squared. You'll see it in that middle section. Here's what you're not going to, don't write this down. This is the way your book words it, and they do CAB instead of ABC, and most students don't like that. We don't do that. It will be acute, you can write this down, if the hypotenuse squared is smaller than the leg squared plus the leg squared. So it will be acute if the hypotenuse squared is smaller than the leg squared plus the leg squared, which is what we had in that last example. 1520 was smaller than 1521. So it will be an acute triangle if the hypotenuse squared is smaller. And then the opposite, if the hypotenuse squared is larger, then that means it's obtuse. So we're looking at the hypotenuse squared. We're looking at C and deciding if it is smaller or larger. So in our last example of today, we're going to be deciding what kind of triangles they are. Verify that the segment lengths form a triangle. Is the triangle acute, right, or obtuse? We did the verifying in Chapter 6, right before final, or midterms. Does anybody remember how to decide if a triangle or 3 lengths form a triangle or not? Yes. So you add the smaller sides, and they have to be greater than the largest side, or longest side. Keep that in mind because there's a section on your test, and you'll have to be able to tell me which one is not a triangle. But that's the first thing we're going to do is decide.
Miss Marshall, can I have Hannah Ferguson and Faith Sanders with their stuff to M15 for maps?
All right, so first thing we're going to do is verify Okay, so we're going to add the two smaller. Is 90 plus 216, is it bigger than 234? Yes. So this does form a triangle. Now we want to see what kind by using a squared plus b squared. I don't write equals because we don't know if it equals. I usually just put a blank. We're just comparing c squared to a and b. So we'll have 90 squared plus 216 squared and compare it to 234 squared. $90 squared is 8,100. 216 squared is a number. 46,656. And then we will compare it to 234 squared. Perfect. 54,756. So we're still comparing. We got to add that the left side. So 8,100 plus 46,656, which is correct. So they equal. So what kind of triangle is this? It's right triangle. The last one, we're going to verify again. So verify by 1 plus 1, is it greater than the square root of 3? So 1 plus 1 is? All right, what's the square root of 3? 1.7. Yeah, so it's bigger. 1 plus 1 is 2, which is bigger than that. So this one works. Now we want to do a squared plus b squared equals c squared. Well, not equals, but a squared plus b squared, and we're going to compare it to c squared. So 1 plus 1 squared, compare it to the square root of 3 squared. What's 1 squared? 1. So 1 plus 1 is 2. And we need to compare it to the square root of 3 squared. What's the square root of 3 squared? 3. So remember, which of these is the more important side? Which is the one we're comparing? The hypotenuse squared. So I usually circle it so I remember which one I'm comparing to the other. So 3, is it smaller than 2 or is 3 bigger than 2? 3 is bigger than 2, so that means this is obtuse. This is an obtuse triangle. So it does take some thought, unless you want to do CAB, which is what they do. So that 3 would be on the left and A and B would be on the right. But that is the end of today.